Hello, welcome. Let's try to solve another Leetcode problem, 1390 for divisors. So we are giving an array nums. Return the sum of divisors of the integers in that array that have exactly 4 divisors. So this means for each of the numbers inside of the nums, so for example, this 21, we're going to have 4 divisors. As you can see from here, we have 4 divisors, 1, 3, 7, and 21. For this number 4, we also have 3 divisors, 1, 2, and 4. For the 7, we have 2 divisors, 1, 7. But we only count the 4 divisors, so 1, 3, 7, and 21. If this number have 4 divisors, we're gonna get the sum of them. So the sum of them would be 32. So we're gonna return 32. Now let's try to solve the problem. Maybe I'm gonna use this one. So we're gonna define a check function. This function is just to check one number. So for this number, we're gonna check if it has 4 divisors or not. So for the divisors function, we can directly use this. So from 1 to, I think the number is just starting from 1 to 10 to the power of 5. This is why it can pass, because the final result is 10 to the power of 4 times the square root of this number. So basically it's going to be 10 to the power of 6. So this is why it should work. So inside it's going to be square root of this number plus 1. And square root of this number going to be an integer. Otherwise, if it is a float number, it is not right. And we're going to prepare a result set. Because we're going to put all numbers inside a set because there's no duplicate. How can we do that? We're going to have a tag. So if this n modular I equal to 0, so this means we're going to put it inside a set. So we're going to put I inside a set. And similarly, we can also put the n divided by I inside of the set. As we put it inside of the set, it means we can check the length of the set, right? So if the length of the result set is equal to 4, so we can return the result. So the length is equal to 4, we're going to return some of the list result because it is a set, so we're going to have a list. Otherwise, we're going to return 0. So this check is just a check for each number. If this number 21, the length is 4, we're going to return 32. So for the next one, if the length is not 4, we just return 0. Now let's go to the main function. Result would be 0, so for n in nums. Result should plus equal to this check function with this number n. And finally, we're going to return the result. Let's just have a double check if there's something wrong with it. So this is just for checking how many divisors, because there's a duplicate for this. For example, this number 4 divided by 2, it's going to have duplicate. Why are we going to use this way? Because here we're going to use a square root of this n plus 1. So it means we're going to only take half of the numbers. So this is why we're going to take another half, n divided by I. But there may be duplicate, so we're going to use a set. And we're going to sum the list of the set if the length is 4. Otherwise, we're just going to return a 0. Now let me try to run it to check. I forget in something wrong. Let's just have a check. So inside it is a 0. It is a string, not as I expected. Let's just check why it is always 0. This is a square root of n. If modular result should add if the length list result. Yes. Let me just print out the result set to check what is wrong with the problem. Maybe let's just run it. I'm going to check this number 21, why it is not 4 numbers inside of the set. Yeah, because it is so slow, maybe I'm gonna copy the code in another tab, maybe here. Yeah, so because here is really slow, I'm gonna put it here to check. So I'm gonna check the result. What is inside the result and why it is wrong? Yeah, let's check what's inside. I only put a 2 inside the so the result only added a 2. So for this 21, it got nothing inside. So for example, this 21, I got nothing inside. Why? So for this number n, so for I in range, I'm gonna have a result. Yeah, because no. I'm gonna put everything inside the result. Yeah, let me just print this n. What is n inside and why it didn't work? Yeah, I have a 21, but inside I got nothing. So for I in range, square root of n, if n modular I equal to 0, I'm gonna put something inside the result set. Yeah, I think everything should be okay. Oh, I didn't? No, yes. Let me print the result just to check what is inside. Yeah, it has 1 and 21, but the length is not 4. If this n modular I, so I should have a I of 3. Yeah, I should have 3 also inside. One 21 with 3. Yeah, you know, for the first time I know how to do it, and the second time I suddenly lose my mind. I think I can still figure it out why. So here I have a result set, and I'm gonna check if it is equal to 0. I'm gonna put it inside the result set. N divided by I, and this is I, and yeah, let me also print out to the I to check what is wrong. So I equal to 1, I put it inside the result set. I print it out, yes, and I print it out, yes. I should have a result set. Yeah, because I needed to define the result set out of the for loop. This is not as I expected. Sometimes I made a silly mistake and cannot find the problem. So I needed to define the result set out of the for loop. Yeah, I don't know why I make such a silly mistake, but now I think it is still okay. Okay, now let's just check. As you can see, the set should be okay. Now let me delete the print and check what is if that is okay. So I'm going to prepare a global variable result set, and I'm going to put it inside, and then I'm going to check it if it is equal to 4. I'm going to return the sum of the list of results, otherwise I'm going to return 0. Now let me submit it. As you can see, it works. So the time complexity is m times the square root of n. So m is 10 to the power of 4, square root of n is 10 to the power of 5. So basically it is the scale of 10 to the power of 6. But we can also speed up a little bit, because from here we don't need to go so far if there are too many divisors. So if the divisors is too many, so if it is more than 4, so we're gonna break the for loop, and we're gonna return this is 0 immediately. Now let's try to check. Now as you can see, it becomes 95% of all submissions. It's really fast. Thank you for watching. See you next time.